proving n minus 2 times by 180. In today's lesson, we will be looking at angles inside a polygon. These are known as interior angles, and we will be looking at the formula n minus 2 times 180 degrees and how this fits in with interior angles in a polygon. Okay, so the first thing is that we need to understand where the formula comes from and why the formula is n minus 2 times 180 for the sum of interior angles. So this here is a formula for sum of interior angles. Okay, so here I have got a rectangle, and I'm just here going to draw myself a little table. So I'm going to say shape. Yep, I'm going to say number of sides to start off with. Okay, so I've got a rectangle and it's a four-sided shape. Now, the sum of interior angles is n minus 2 times 180, and why? And we will look at working out the sum of the interior angles as well. What you need to do is you need to see how many triangles you can draw in this shape. So to do that, you pick a point on your shape. So pick a corner. I'm going to pick this corner up and you join it to every other corner. So that there and that corner there is already joined up, so I don't need to draw a line. But that corner to that corner is not joined up, so I can draw myself a line. That corner to that corner is joined up, so I can't draw a line there. And there you are, I've made 1 and 2 triangles. Okay, so I'm going to write number of triangles. Just draw a little thingy. And then sum of angles or interior angles. Okay, I've made 2 triangles. Well, what do we know about the angles in a triangle? We know that angles in a triangle add up to 180 degrees, don't they? So in this triangle here, the angles will add up to 180. And then this triangle here, the angles will add up to 180. So in total, the angles in this shape should add up to 360 degrees because each triangle is 180 degrees. The total of angles in a triangle is 180 degrees. Okay, so let's have a look at another shape then. Let's have a look at this shape. This is 1, 2, 3, 4-sided shape, but it's a different shape this time. It's a trapezium. So again, let's have a look and we can compare this time because again, we've got a 4-sided shape. So again, you pick a corner, that corner, and join it to all the other corners. That to that corner is already joined. That corner to that corner, nope. That corner to that corner, nope. So you can see I can make 2 triangles. Okay, so again, in each triangle, the angles are 180 degrees. Yeah, so for example, if you don't understand that, these 3 here will total up to 180. And then obviously these 3 here would total up to 180. So we've got 2 triangles. Each triangle, the angles total up to 180. So I made 2 triangles, and that's a total of 360 degrees in that shape. The next shape here is a pentagon. It's 5 sides. 1, 2, 3, 4, 5-sided shape. Okay. Let's see how many triangles I can make in this pentagon. So again, you pick a point or a corner. There we are. Join it to all the other corners. That to that corner is already joined. I've got that corner, and that corner as well. That to that, not joined. That to that, not joined. That to that is joined. And this time I've made 1, 2, 3 triangles. So again, I've made 3 triangles. Well, this triangle here, the angles will add up to 180. This triangle here, the angles will add up to 180. And this one here also, the angles add up to 180. So we've got 180, add 180, add 180, or 180 times by 3, because we've got 3 triangles. That's 540 degrees. So the angles in a pentagon would add up to 540 degrees. Again, it doesn't matter what, if the shape is different or if the shape is, doesn't look like a regular pentagon, the answer will still be the same. So for example, here we had a rectangle and we had a trapezium. It's a four-sided shape, and you can see I can make two triangles with them, and the sum of the angles inside a four-sided shape is 360 degrees, regardless of what the shape looks like, as long as the number of the sides are the same. So this here is a regular pentagon. This here is an irregular pentagon, and we'll see that the angles inside an irregular pentagon should still add up to 540 degrees. So pick corner, and I'm going to join it to all the other corners. Okay, that to that is joined, that to that, and then that one to that one, and that one to that one's joined. And you can see I can make 1, 2, 3 triangles from this. So again, I've got, that was a regular pentagon. This is an irregular pentagon. Still 5 sides, still I can make 3 triangles, and the angles add to 540 degrees. Okay, let's have a look at another shape then. This one here, this time, I've got 1, 2, 3, 4, 5, 6, 7. I've got a 7-sided shape. Okay, that's a hexagon. Okay, let's double check. We've not got a hexagon anyway. 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, yeah, okay. Right, let's write that in. Okay, okay, so 7-sided shape is a heptagon. Oops, not a hexagon. I thought I already had a hexagon drawn here, but I haven't. But we can work that out. Right, heptagon is 7 sides. Let's see how many triangles I can make. Okay, there we are. That corner to that corner is joined. That corner to that corner is not joined. That corner to that corner, again, not joined. That corner to that corner, not joined. That corner to that corner, not joined. And then that corner to that corner is joined. So how many triangles have I made? 1, 2, 3, 4, 5. I've made 5 triangles. So heptagon is 7 sides, and I've made 5 triangles. Again, each triangle angles add up to 180, 180, 180, 180, and 180. So 180 times 5 is 900 degrees. So the angles in a 7-sided shape would all add up to 900 degrees. Okay. Let's do another one then. This one here is 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8-sided shape, which is a octagon. How many triangles can I make in an octagon? Well, if I pick a corner, I'm just going to pick this one. That to that is joined. That to that, no. That to that, no. That to that, no. This one, and this one. So I've made 1, 2, 3, 4, 5, and 6. Okay, so 6 triangles. Okay, and again, each triangle angle will add up to 180. So the angles in that shape would add up to 180. This one 180. This one 180. 180 in this one. 180 this one, and 180 in this one. Okay, so that's 180 times by 8 because there are 8 of them, and that's 1,440 degrees. Okay, so angles in 8-sided shape would add up to 1,440 degrees. Okay, so you can see here that the formula above is n minus 2 times by 180. Okay, well, where does that come from and what does it mean? So n actually is the number of sides of your shape. Okay, number of sides of your shape. Well, if I've got a four-sided shape, I can make two triangles. If I've got a five-sided shape, I can make three triangles. If I've got a seven-sided shape, I can make five triangles. And if I've got an eight-sided shape, I can make six triangles. Can we notice a pattern between the number of sides and the number of triangles we can make? So if I highlight this for you, is there a relationship between them? Well, you can see actually, if I subtract 2 from the number of sides, I will get the number of triangles in my shape. 4 take away 2 is 2. 5 take away 2 is 3. 7 take away 2 is 5. And 8 take away 2 is 6. And that's where n minus 2 comes from. N minus 2 will tell you the number of triangles you can make in your shape. And then you just times by 180 because obviously each triangle, the angles would add up to 180 degrees. And once you know your number of triangles, you times by 180 to work out the total amount of what your angle should total up to in a shape. So let's try another one. Okay, so let's try we're just going to try a different size. Let's say we've got a 12-sided shape. Well, how many triangles can I make? Well, I'm going to subtract 2 to get the number of triangles, which is 10. Well, one triangle, the angles would add up to 180, but I've got 10 triangles. So I'm going to do 10 times 180, which is 1,800 degrees. What if I had a 25-sided shape? Well, 25 take away 2 is 23. So that means I could make 23 triangles in my 25-sided shape. Then I've got to do 23 times 180, which is 4,140 degrees. So that's what the angles would total up to in a 25-sided shape. Okay, so what I'm going to do is I'm just going to draw myself a pentagon. As best as I can. Okay, right, so I'm going to say that this angle here is 114 degrees. I'm going to say this angle here is 62 degrees. We're going to assume this is an irregular pentagon. I know it looks like a regular pentagon, but we're just going to say it's irregular. I'm going to say that angle there is 55 degrees. This angle here is 98 degrees. We're just making random numbers up now. And I need to work out this angle here, which is x degrees. Okay, sum of angles inside a shape. Well, I know this is a 5-sided shape. I'm going to subtract 2 to work out the number of triangles. That's 3. I'm going to have 3 triangles in my shape. I'm going to do 3 times 180, which is 540 degrees. So it means that in my pentagon, the angles should add up to 540 degrees. Well, what do the angles add up to so far? I've got 114, add 62, add 55, add 98. So if I add that up, 114, add 62, add 55, add 98, gives me 329 degrees. Okay, let's change that to 155. Okay, so if I go back, just because I've made these numbers up, that's better. Okay, when I add these up, I end up with 429 degrees. Well, the missing angle, well, all the angles add up to 540. I want the missing one. So I'm going to do 540 minus 429. And I end up with 111 degrees. So that missing angle there is 111 degrees. Okay. Let's draw another shape. Okay. So this time, okay, let's draw another shape. Okay, right, if I try and draw that again. Okay. Okay, there we are. 1, 2, 3, 4, 5, 6. I've got a 6-sided shape. So let's write in the angles. Okay, and then we'll try and work out the missing one. Again, it looks like a regular. We'll say it's a regular hexagon. It's a 6-sided shape this time. Okay, so let's add, or let's write down the angles in this shape. Okay, so I'm going to have, let's say that's 89 degrees plus 124. Okay, I'm going to say that one is 110. I'm going to say that one is 145. Okay, this one here I'm going to say is 105. And I'm going to make that as 189. Okay, and just going to double check this. Yep, okay, right. So I've got a 6-sided shape. I'm going to subtract 2 to get the number of triangles, which is 4. Then I'm going to times by 180 to work out the total number of triangles, or what the total is altogether, which is 720 degrees. So all the angles would add up to 720 degrees. Now we need to work out the missing angle. Okay, so I'm going to add up all the angles. I've got 189, add 124, add 110, add 145, and I had 105. I'm going to add them up. Okay, when I do that, I get 673 degrees. But my total of the shape, the angles, should be 720 degrees. But at the moment, the angles add up to 673. So I want the missing one. So I'm going to do 720 minus 673. Okay, and I get 47 degrees. So our missing angle there is 47 degrees. Okay, so these are the types of examples that you can have when looking at sum of interior angles. Obviously, we know what the angles total up to, and we can use this information then to work out the missing angles. Just a little bit of a different type of question. Let's say I've got a regular heptagon, which is a 7-sided shape. Regular means all the sides, so all sides and angles are equal. And we're going to work out what all the angles add up to in 7-sided shape and what each angle would be. Well, I'm going to do 7 take away 2, which is 5 for the number of triangles. Then I'm going to times by 180 to get 900 degrees. Now, all the angles in a 7-sided shape should add up to 900 degrees. However, a regular shape means all the sides and all the angles are the same. Well, if all the angles are the same, I've got 7 of them, so I'm going to do 900 divided by 7, and I end up with 128.571428 recurring. I'm just going to round that to 128.6 to 1 dp. Oh, sorry, there you are, degrees, 128.6 degrees, and that is what each angle would add up to. So this was today's lesson to do with interior angles, the sum of interior angles, and then obviously using that to work out missing angles or an individual angle. Hope this lesson was useful for you. Thank you for watching.